All right, so we're going to move on to example 6, which is involving the discriminant to determine the number of real solutions to the following equations. So here, notice that we want to state the number of real solutions, their ultimate goal. Now, notice up here in the chart, the discriminant and solution of a quadratic equation, that we use what's known as the discriminant. The discriminant is b squared minus 4ac. We're not really dealing with it too much, but you can look back at the quadratic formula, and that's addressed in this section. And you'll notice that the b squared minus 4ac is the part that's under the square root. All right, I'm not going to go into that too much about the quadratic formula, but it's a good idea to look back at that if you're interested to know where this came from. All right, so what we see is if we're in the standard form, ax squared plus bx plus c equals 0, that's the standard form that's mentioned at the beginning of the section. And we'll see that if we plug in the values a, b, and c into the discriminant, then there's 3 different possibilities. B squared minus 4ac can be positive. It could be greater than 0, meaning, positive, a positive solution. If that's true, then we have 2 distinct real solutions. 2 distinct real solutions. That's if we have greater than 0. If we have equal to 0, then we have 1 real solution. And then what you'll notice is you'll have a solution that the double solution. We won't go into that too much, but the most important thing is 1 real solution. And then the last possibility is if b squared minus 4ac is less than 0, then you have 2 distinct non-real complex solutions. So you have 2 imaginary solutions that involve I in imaginary solutions. But what you'll realize is if we want to state the number of real solutions, 2 distinct non-real complex solutions is telling us that there's 0 real solutions. Okay, so so keep in mind that you may be asked how tell what type of solutions you have. Then you wouldn't want to say that there's 2 complex solutions. And if they asked for how many real solutions, you would say 0 real solutions if you end up getting a negative for b squared minus 4ac. All right, let's go into A. So notice the best way to go about this is to label what A, B, and C are for each problem. So for A, we have A equals, and so that's the number in front of the x squared, so that's 2. You have B is the number in front of the x, and so remember the negative comes along with the 5. So that you want to look at the sign in front of the number. So we have negative 5, and then we have C equals positive 1. It's the constant. All right, so after you figure out what A, B, and C are for each for the problem, you just plug it in for B squared minus 4AC. So B squared, so that's negative 5 squared minus 4, and then A is 2, and C is 1. We simplify this to 25 is negative 5 squared, and then 4 times 2 times 1 is 8, so it's minus 8, and that gives us 17. And since 17 is a positive number that's greater than 0, we're in the first option, it's greater than 0, then we have two real solutions. So we have two real solutions, two real distinct solutions. Now realize we're not actually solving like for the exact value of x. We just want to know how many solutions, real solutions, we'll have. Okay, so now we're moving on to B. Let's do B up here. B, we have A. The A value is 3 in this case. The B value is 6. And the C value is 7. So in this case, we have B squared minus 4AC. B is 6, so that's 6 squared minus 4 times 3 times 7. That gives us 36 is 6 squared minus 4 times 3 times 7. That is 12 times 7 is 84. And 36 minus 84 is, trying to do that in my head, negative 48, I believe. But either way, I'm pretty sure I have that correct. But either way, yeah, I think I have it correct. Either way, we can clearly see that 36 minus 84 is less than 0. It's a negative solution. And from that, we have the yellow option, which is two distinct non-real complex solutions. So two imaginary solutions, or in other words, so for this, we want to say 0 real solutions because they're asking about a number of real solutions. So 0 real solutions. So 0 real solutions, and another way of expressing this as two complex or also imaginary solutions. So and another thing that they mention is the solutions are conjugates of each other. I would encourage you to look that up. They discuss this in the text. We're not going to emphasize that too much in the class, but you may want to look into that. But for this, we're looking at real solutions, so 0 real solutions. Now for part C, I'm going to leave this up to you, but I'm just going to show you what the values for A, B, and C for you to plug in. So in this case, A, it's a little tricky, but A, there's no number in front of the x squared, so that tells you that A is equal to 1, because x squared is also 1 times x squared. And then B is 6, and C is 9. Go ahead and plug that into your B squared minus 4AC and see what you end up with. And let me know if you have any concerns about that. You either have two distinct solutions, one real solution, or two distinct non-real complex solutions, which is 0 real solutions. All right, let me know if you have any concerns.